Okay, perfect. So everybody has this worksheet in front of them titled Finding Intercepts. Okay, perfect. So we are interested in finding the X and Y intercepts. Okay, so what are they? The X-intercept is just the point at which the graph hits the X-axis. That's it. So no matter where it crosses, so check this out. If I have a graph, right, doesn't matter what it looks like. Let's say, I don't know, it does blah, 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 blah. Okay, it crosses the X-axis right there, doesn't it? What? I don't know what the X value is, but I sure do know the Y value, don't I? What's the Y value right there? Oh, what's that? You said nothing because it's 0, right? Smart. Yes, the Y value is 0 right here. I don't know what the X value is. It's something, but the Y value is always going to be 0. No matter where a graph crosses the X-axis, isn't Y going to be 0? Right? If we're talking about the coordinate, this is going to be some X comma some Y, right? That Y has to be 0 because I'm not above the X-axis or below, I'm on it. So the Y value is 0. If I want to figure out what that X value is, I can just take 0 and plug it into my equation. And then solve for X. That's literally all I have to do. I plug in 0 for Y, solve for X. That's where that thing is crossing the X-axis. That's it. And then if I want to find the Y-intercept, I basically do the same thing. I'm just going to plug in 0 for X because again, think about it. Again, you have a graph, say it does blah, 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 blah. Where does it cross the Y-axis? Right here. I don't know what that Y value is. If I was going to give that an ordered pair, but I do know the X coordinate, don't I? Isn't the X coordinate 0? It's going to be a 0 comma some Y value. I just don't know what it is yet. But I can find it by just plugging in 0 for X and then solve for Y. That's literally all you have to do. So let's take a look at the examples down at the bottom. So for the first one, let's solve for the X-intercept. So if I'm solving for the X-intercept, that means I plug in 0 for what, X or Y? Y, yeah, whatever intercept you're solving for, you plug in 0 for the other one. So I literally just take my equation and instead of writing Y, I write 0 equals 2x plus 7. Let me zoom in a bit. And now I just solve this equation for X. That's it. Oh, that's easy. Okay, minus 7, minus 7. Divide by 2. I get the X-intercept. I guess stick this. X-intercept will happen at the point -7/2, comma 0. Right? Because the Y value was 0. I plugged in 0 for Y, and that's the X that came out. You with me? Now, if I want to solve for the Y-intercept, this one's kind of easy because you already know what the Y-intercept is, right? Because it's in slope-intercept form. So we already know that it's 7. But watch, if you didn't realize, I would do the same thing. If I'm going to find the Y-intercept, let's plug in 0 for X. Y equals 2 times 0 plus 7. Oh, well, what do you know? Yeah, it's just 7. So that means my Y-intercept is at 0, comma 7. Isn't that easy? Yeah. Now, does it get trickier? Of course, it always does. Just when you have more complicated equations. So let's try the one below it.
Pardon the interruption. Nate Grosha, please report to the main office. Nate Grosha.
Okay, let's see. All right, so So the one below it, I'm gonna do the same thing. Looks like I give myself a little bit more space here. So if I want to find the X-intercept, I'll do it over here. I plug in 0, 4, what? If I want to find the X-intercept, plug in 0, 4, Y, you got it. So 0 equals X minus 3 squared minus 4. All right, cool. Now we just solved this thing for X. What would you do? Go ahead. So you could FOIL that out if you wanted. Grace. Yeah, you can do that too. Either way, you can do whatever you like. I would do that way just because I think it might be a little less work. So if I add 4 to the other side, I'm going to get this. And now I can take the square root of both sides. What do you have to remember though when you take a square root? Yes, positive and negative. X minus 3, and then just add that 3 over to the other side. So what does this mean? X is going to be 5 or 1. What does that mean about this graph, ladies and gentlemen? Jake?
Well, it's a quadratic graph. So that's 2x intercepts.
Exactly. Think about what a quadratic looks like when you graph it. Isn't it a parabola that U-shape? So isn't it absolutely possible that it hits the x-axis twice? Yeah. Will all quadratics hit the x-axis twice? No, not necessarily. They could hit just once if the vertex is right on the x-axis, or it's possible that they don't hit at all. But anyway, this one does hit and it hits twice. So I have 2 x-intercepts. One of them is going to be at 5, 0, and the other one's going to be at 1, 0. Does that make sense? And now I do the same thing for y. So to find the y-intercept, I really don't have enough room on here. That's okay. So y-intercept, I'm going to plug in 0 for x. So I'll have y equals 0 minus 3 squared and then minus 4. And then again, I'm just going to go ahead and solve this. I get negative 3 squared is 9 minus 4. Looks like I just get 5. Could a quadratic have more than one y-intercept? No. It's only ever, well, hold on, let me not answer that question. Could a quadratic not have any y-intercepts? We said that so for x-intercepts, we said it could have 2, it could have 1, it could have none. Do y-intercepts work the same way? We're talking about a parabola. Is it possible that a parabola never crosses the y-axis? The answer is no. It will always cross. Why, Mrs. Xavier? Are you sure? Check it out. So you have a parabola. Let me zoom out here. Let's just say, I don't know, say you got one way over here. That thing's never going to cross the x-axis. I agree with you there. But all parabolas, they keep going out, right? This is eventually going to keep going out and out and out and out. So eventually it's going to hit that y-axis somewhere, no matter where you put it. Oh, interesting. Could it ever hit more than once? Do you have a parabola that hits the y-axis more than once? No. Every parabola is only going to have one y-intercept. Oh, gosh, math, love it. Okay, so our y-intercept has got to be 0, 5. All right, how do we feel? Try the absolute value one on your own. See if you can do that one. I think I'm going to do it just on the back side because I need more space. Oh. I got an answer for the first one, for the X-intercept? What'd you get? 2 and -4. Sounds right? Okay. By the way, I just want to point out one thing that I just want to make super clear that you should never ever do. You should never get your X-intercept and then get your Y-intercept and then write the answer as like that's an ordered pair. That's totally wrong. That's not a thing. That's when you're solving systems, right? You get a value for X, you get a value for Y, and then you write it as an ordered pair. That's not what's happening here. You have completely different points. You can't like join them together into one ordered pair. Doesn't work that way. Okay, so any hoosers, this one, I want to solve for the X-intercept first. And by the way, it doesn't matter which intercept you solve for first. That's totally up to you. I'm going to plug in 0 for Y. Absolute value of X plus 1 minus 3. I have an absolute value. You guys remember how to deal with them. I'm going to get the absolute value by itself. And then the only way to break down those bars is to rewrite it twice. Once equal to 3 and then once equal to -3. Remember? So I'm going to have one time just like it is. And then the other time is going to be equal to -3. And then I just solve each one separately. So I get 2 and yeah, a -4. So this one just so happens to have 2 X-intercepts. And they are at 2, 0 and -4, 0. See how they're separate points? Don't like put them together and say it's at like 2, -4. It's not even on the x-axis. They're separate points. And then Y-intercept, I do the same thing. Let's plug in a 0 for X. Okay, there it is. And now all I gotta do is solve. Absolute value of 1 is just 1. I got a -2. Did you? Cool. So that point would be at 0, -2 for that Y-intercept. Okay, did you try the last one yet? Try it real quick if you haven't already. Hi, Ethan. Are you stuck at the first line? I thought you might be. Okay, so if you plug in 0 for Y, right? Now I do want to solve for X. You don't want to, if your first instinct was, oh, let me just divide both sides by X, you can't do that because you don't know what X is. What if X were 0? Now you've just like imploded the universe. You can't do that. So what I can do, I do have a radical here. I'd love to get rid of it. I can square both sides and it's not going to be that bad. So if I square this whole side and I square this whole side, right? So that's just 0. Now, remember what's going on this side. If I square that, I'm doing X times 4 minus X squared under the root times another X times another root, 4 minus X squared. So look what comes out. I have X times X is X squared. And then when you have this thing times itself, don't you just get what's underneath the root? So I get 4 minus X squared. Okay, now I can distribute and I should be able to solve from here. 4x squared. Oh, actually, I guess I wouldn't actually distribute because I'm just going to factor it right back out. So once I have it factored like this, now I can just set each factor equal to 0. So x squared will equal 0 and 4 minus x squared will equal 0. And now I can just solve each one. So one of my solutions, if I square root both sides, I'm going to have 0, and I'm also going to have, let's see, that would just be x squared equals 4. Square root u, square root u, and get positive -2. Yes.
Can you, like, because the numbers inside of the radical are being used, would you be able to?
Take the square root of each?
Is where we do?
No, because it's a binomial.
Okay.
If it was 4 times x squared, you could.
Okay.
But because there's if you have a plus or minus there, you can't do it that way, unfortunately. Okay, so this one appears to cross the x-axis. I've got it at 3 times. And so getting 0 as one of my solutions counts. So that's going to cross at 0, 0, should be crossing at the origin. And it's also going to cross at +2 and -2. So my X intercepts here would be 0, 0. 2, 0. And -2, 0. Luckily, solving for the y-intercept is actually way easier, right? Because all the x's basically cancel out. Now, I do have more than one x. Which x do I plug 0 into? All of them. If x is 0, all the way throughout. So when I go to do my y-intercept, let's see, y-intercept, plugging in a 0 for x, I'm just going to get this. Y equals 0 times, you don't even have to keep going because 0 times anything is just 0, but there it is. There we go. Which makes sense because I already knew it was going to cross the origin. So there we have it. All right, how do we feel? Okay, I mean, the process, the idea is easy. It's just making sure that you solve it correctly. Some are easier than others, but hopefully it's easy enough to understand. Okay, if I want to find it, I just plug in 0 for this and 0 for that. We feel okay-ish? All right, that's the spirit. All right, let me give you this. Okay, so in the spirit of a half day, why don't we? So we just do the odds? All right. Okay, let me stop this.